All right, so before we start looking at the details of that reshape package within R, we need to have an understanding about how data can look, how it can be in different forms. So we're going to distinguish between long and wide formats. Here I have entered just kind of a toy data set here that we'll call trial. And we can see here we have IDs, and then you can think of these as different trials of, say, an experiment where full replication of every factor for every subject is achieved. Okay, so we can do all kinds of things to restructure this data. First of all, we may need to whoops, I started on the wrong line. We may need to move the data into so-called long format. So if we simply, don't worry too much about the function, because I'm going to teach you more reshape here, but melt is a wrapper function for reshape. And notice what it did to our data. So we've gone from this formatting, which we'd call the wide formatting here, because we have each row is a unique ID. Okay, so that's really what you should be looking at if you're trying to distinguish between wide and long formatted data, is whether or not each row is distinctive to the subject. Once we get it into long format, we see that we have multiple rows for each subject, and that's because each row indicates when a particular value was obtained in the data collection. So most of the time for modeling purposes, we actually need data in long format. That's why this wrapper function melt exists, because often our data looks like this, and we actually need it like this so we can model value as a function of the variable with controlling for the heterogeneity of the ID or the subject. So keep this in mind as we go through the next part of the notes. This would be the long format, this would be the wide. So when I make reference to that, that's what I'm talking about. Okay, so if we go ahead and take a look now at the code, we can see here we have some data that's going to be in wide format. We want it to go again into long. So this is going to be exactly what we just saw in the R code. It's just going to be a little bit more complex than the first example. That's why I wanted to show you that first example. So you can see the simple first, and now the more complicated. So you can see we have a unique ID for each row. We have variable X, T1, and T2. Note that T1 and T2 are intentionally used so that we have those suffixes to make the reshaping easier. This is a really nice way to maybe say, you know, time point 1, time point 2, and it will make it easy to reshape if we use this kind of consistent naming with the suffixes having to do with the number of observations for each subject. X here you might think of as like a covariate. That isn't part of the experiment, but something that could affect the outcome of the experiment. So here we're using, rather than melt, we're using the original and more versatile reshape function. So we put in the wide data frame here. We're going to say that we want T1 and T2 to vary, and that means those are the ones that we want transformed, and we want them transformed into a long form. Okay, so when we run this, and here's I should mention, this is the simplest possible call. Then this would be a more carefully coded call where we have certain things done. For example, we have our time variable is going to be visit. So this is going to create a variable so that it tells us when we're at time point 1 versus time point 2. And we're going to create a new ID variable called index. And since we're creating that new ID variable, we no longer need ID in that set anymore. So we could leave ID, but we may as well just drop it. Okay, so let's take a look at how this might look within R and make sure we understand. Okay, so now we're going to run this set of code. I'm going to just make sure we understood from before what that original wide form data looks like. So this is almost identical to the first example. We're just going to use a more complicated call now. And so when we run just the reshape function like this without all those options, what we get is, again, our ID variable. We get our X, and notice how it is repeated correctly. We get our time variable, and we get an ID variable also repeated here. And T here stands for our observation. So notice how T corresponds to the T.1 and T.2 and has the same prefix. And so that helps you recognize. And if it's, time point 1, time point 2, it'll just say time here. If we run it using our other options, the only thing we're going to see is those renames of those columns. So instead of saying ID here, we see index. T's the same. Rather than time, we see visit, and we have X, and then of course ID got dropped because we don't need it any longer. Notice that the row names are included. Of course, this is not, let me clarify, this is not a column within our data frame. Our data frame just has 1, 2, 3, 4 columns now, but these are row names within our data frame. So make sure you distinguish between those. What's nice in R2 is that once you've reshaped a data frame, it has attributes that make it easy to just convert from wide to long to wide, back and forth. So we can take this reshape long, and because of the structure that's been enforced by the reshape function, we can easily put it back into wide format whenever we want. Okay, so we can also go the opposite direction. So we can reshape a long data frame into wide format. So run this on your own. Make sure you understand it. Let's make sure we understand first, though, before you run it, kind of the structure of these data. Again, we have ID that's now repeated 1 to 5 2 times. So this will be a list 1 to 5, then another list 1 to 5 stacked below. We have the X variable, the covariate repeated. We have the T repeated. So this is going to look like reshape long. Okay, now we're going to convert back to the wide format. This does not have the nice formatting that reshape long has, though, because we're creating it as a data frame command. So we need to specify, when we use the reshape function here, we need to specify what our ID variable is going to be. So we name that. What is our variable to be transformed? It needs to be that T. So notice T is going to contain those letters that were also up there. Then what is our time variable? Well, we're going to call that time. We're going to go to the wide direction. So this will make it look back like our original wide data frame here. And then once it's reshaped, you can easily convert back to long. Okay, so the stack function will actually take multiple vectors and just concatenate them. This is useful. I really only use these for very simple data frame structures, or I should say vector objects is what this is most useful for. Of course, you can pull out any variable within your data frame and it's instantly a vector object, so it can be used like that. So let's say we have a data frame where we have the label variable and then the value. This is just going to be a sample of values, so if you run this, it'll look different than when I run it. We can unstack it using the function value as a function of label. So it'll take these labels that are repeated and create a row for each label. Then we could restack them using just the stack function. We can be very particular and select which columns to stack, so we could just stack A and B and leave out C, and so on. So try that out. This is probably less useful in my mind than reshaping, but has its place. Finally, missing data. This is pretty simple to deal with. NA omit just removes missing data. don't just use that. Of course, sometimes missingness is important and we need to think about why it occurs and how we can use imputation methods to replace that data when possible. So this is not a trivial function, and we should be very careful about using it. There is a related function, complete cases, which just contains a logical vector indicating which rows have no missing data. This is really useful for segmenting your data. So if you want to remove missing data, you want to use NaOmit, but with the idea that we need to be careful doing that. But if we just want to subset the complete data to maybe run the analysis with and without the complete data, you can use that complete cases. And then we haven't changed substantively anything about our data frame that we're operating upon.